Section 1.5, Factoring Polynomials. Learning Objectives. In this section, you will 1. Factor the greatest common factor of a polynomial. 2. Factor a trinomial. 3. Factor by grouping. 4. Factor a perfect square trinomial. 5. Factor a difference of squares. 6. Factor the sum and difference of cubes. 7. Factor expressions using fractional or negative exponents. Imagine that we are trying to find the area of a lawn so that we can determine how much grass seed to purchase. The lawn is the green portion in Figure 1. Figure 1. The area of the entire region can be found using the formula for the area of a rectangle. A equals LW equals 10x dot 6x equals 60x squared units squared. The areas of the portions that do not require grass seed need to be subtracted from the area of the entire region. The two square regions each have an area of A equals S squared equals 4 squared equals 16 units squared. The other rectangular region has one side of length 10x minus 8 and one side of length 4, giving an area of A equals LW equals 4 times open parenthesis 10x minus 8 closed parenthesis equals 40x minus 32 units squared. So the region that must be subtracted has an area of 2 times open parenthesis 16 closed parenthesis plus 40x minus 32 equals 40x units squared. The area of the region that requires grass seed is found by subtracting 60x squared minus 40x units squared. This area can also be expressed in factored form as 20x open parenthesis 3x minus 2 closed parenthesis units squared. We can confirm that this is an equivalent expression by multiplying. Many polynomial expressions can be written in simpler forms by factoring. In this section, we will look at a variety of methods that can be used to factor polynomial expressions. 1.5.1. Factoring the greatest common factor of a polynomial. When we study fractions, we learn that the greatest common factor, GCF, of two numbers is the largest number that divides evenly into both numbers. For instance, 4 is the GCF of 16 and 20 because it is the largest number that divides evenly into both 16 and 20. The GCF of polynomials works the same way. 4x is the GCF of 16x and 20x squared because it is the largest polynomial that divides evenly into both 16x and 20x squared. When factoring a polynomial expression, our first step should be to check for a GCF. Look for the GCF of the coefficients, and then look for the GCF of the variables. A. Greatest common factor. The greatest common factor, GCF, of polynomials is the largest polynomial that divides evenly into the polynomials. How to? Given a polynomial expression, factor out the greatest common factor. 1. Identify the GCF of the coefficients. 2. Identify the GCF of the variables. 3. Combine to find the GCF of the expression. 4. Determine what the GCF needs to be multiplied by to obtain each term in the expression. 5. Write the factored expression as the product of the GCF and the sum of the terms we need to multiply by. Example 1. Factoring the greatest common factor. Factor 6x cubed, y cubed, plus 45x squared, y squared, plus 21xy. Solution. First, find the GCF of the expression. The GCF of 6, 45, and 21 is 3. The GCF of x cubed, x squared, and x is x. Note that the GCF of a set of expressions in the form x to the power of n will always be the exponent of lowest degree. And the GCF of y cubed, y squared, and y is y. Combine these to find the GCF of the polynomial, 3xy. Next, determine what the GCF needs to be multiplied by to obtain each term of the polynomial. We find that 3xy, open parenthesis, 2x squared, y squared, closed parenthesis, equals 6x cubed, y cubed. 3xy, open parenthesis, 15xy, closed parenthesis, equals 45x squared, y squared, and 3xy, open parenthesis, 7, closed parenthesis, equals 21xy. Finally, write the factored expression as the product of the GCF and the sum of the terms we needed to multiply by. Open parenthesis, 3xy, closed parenthesis, multiplied by, open parenthesis, 2x squared y squared, plus 15xy, plus 7, closed parenthesis. Analysis. After factoring, we can check our work by multiplying. Use the distributive property to confirm that open parenthesis, 3xy, closed parenthesis, multiplied by, open parenthesis, 2x squared y squared, plus 15xy, plus 7, closed parenthesis, equals 6x cubed, y cubed, plus 45x squared, y squared, plus 21xy. Try it number 1. Factor x, open parenthesis, b squared, minus, a, closed parenthesis, plus 6, times, open parenthesis, b squared, minus, a, closed parenthesis, by pulling out the GCF. 1.5.2. Factoring a trinomial with leading coefficient 1. Although we should always begin by looking for a GCF, pulling out the GCF is not the only way that polynomial expressions can be factored. The polynomial x squared, plus 5x, plus 6, has a GCF of 1, but it can be written as the product of the factors, open parenthesis, x, plus 2, closed parenthesis, and, open parenthesis, x, plus 3, closed parenthesis. Trinomials of the form x squared, plus bx, plus c can be factored by finding two numbers with a product of c and a sum of b. Trinomials of the form x squared, plus 10x, plus 16, for example, can be factored using the numbers 2 and 8 because the product of those numbers is 16 and their sum is 10. The trinomial can be rewritten as the product of, open parenthesis, x, plus 2, closed parenthesis, and, open parenthesis, x, plus 8, closed parenthesis. A. Factoring a trinomial with leading coefficient 1. A trinomial of the form x squared, plus bx, plus c, can be written in factored form as open parenthesis, x, plus p, closed parenthesis, multiplied by, open parenthesis, x, plus q, closed parenthesis. Where p, dot, q, equals, c, and p, plus q, equals, b. Q and a. Can every trinomial be factored as a product of binomials? No, some polynomials cannot be factored. These polynomials are said to be prime. How to? Given a trinomial in the form x squared, plus bx, plus c, factor it. 1. List factors of c. 2. Find p and g, a pair of factors of c with a sum of b. 3. Write the factored expression, open parenthesis, x, plus p, closed parenthesis, multiplied by, open parenthesis, x, plus q, closed parenthesis. Example 2. Factoring a trinomial with leading coefficient 1. Factor x squared, plus 2x, minus 15. Solution. We have a trinomial with leading coefficient 1, b, equals 2, and c, equals negative 15. We need to find two numbers with a product of negative 15 and a sum of 2. In the table below, we list factors until we find a pair with the desired sum. Factors of negative 15. Sum of factors. For 1, negative 15, the sum of the factors is negative 14. For negative 1, 15, the sum of the factors is 14. For 3, negative 5, the sum of the factors is negative 2. For negative 3, 5, the sum of the factors is negative 2. Now that we have identified p and q as negative 3 and 5, write the factored form as open parenthesis, x, minus 3, closed parenthesis, multiplied by, open parenthesis, x, plus 5, closed parenthesis. Analysis. We can check our work by multiplying. Use FOIL to confirm that. Open parenthesis, x, minus 3, closed parenthesis, multiplied by, open parenthesis, x, plus 5, closed parenthesis, equals, x squared, plus 2x, minus 15. Q and A. Does the order of the factors matter? No. Multiplication is commutative, so the order of the factors does not matter. Try it number 2. Factor, x squared, minus 7x, plus 6. 1.5.3. Factoring by grouping. Trinomials with leading coefficients other than 1 are slightly more complicated to factor. For these trinomials, we can factor by grouping, by dividing the x term into the sum of two terms, factoring each portion of the expression separately, and then factoring out the GCF of the entire expression. The trinomial 2x squared plus 5x plus 3 can be rewritten as open parenthesis 2x plus 3 closed parenthesis multiplied by open parenthesis x plus 1 closed parenthesis. Using this process, we begin by rewriting the original expression as 2x squared plus 2x plus 3x plus 3, and then factor each portion of the expression to obtain 2x open parenthesis x plus 1 closed parenthesis plus 3 times open parenthesis x plus 1 closed parenthesis. We then pull out the GCF of open parenthesis x plus 1 closed parenthesis to find the factored expression. A. Factor by grouping. To factor a trinomial in the form a x squared plus bx plus c by grouping, we find two numbers with a product of a, c, and a sum of b. We use these numbers to divide the x term into the sum of two terms, and factor each portion of the expression separately, then factor out the GCF of the entire expression. How to? Given a trinomial in the form a x squared plus bx plus c, factor by grouping. 1. List factors of a, c. 2. Find p and g, a pair of factors of a, c, with a sum of b. 3. Rewrite the original expression as ax squared plus px plus qx plus c. 4. Pull out the GCF of a, x squared plus px. 5. Pull out the GCF of qx plus c. 6. Factor out the GCF of the expression. Example 3. Factoring a trinomial by grouping. Factor 5x squared plus 7x minus 6 by grouping. Solution. We have a trinomial with a equals 5, b equals 7, and c equals -6. First, determine a, c equals -30. We need to find two numbers with a product of -30 and a sum of 7. In the table below, we list factors until we find a pair with the desired sum. Factors of -30. Sum of factors. For 1, -30, the sum of the factors is -29. For -1, 30, the sum of the factors is 29. For 2, -15, the sum of the factors is -13. For -2, 15, the sum of the factors is 13. For 3, -10, the sum of the factors is -7. For -3, 10, the sum of the factors is 7. So, p equals -3 and q equals 10. 5x squared minus 3x plus 10x minus 6. Rewrite the original expression as a x squared plus px plus qx plus c x open parenthesis 5x minus 3 closed parenthesis plus 2 times open parenthesis, 5x, minus 3, closed parenthesis. Factor out the GCF of each part. Open parenthesis, 5x, minus 3, closed parenthesis, multiplied by, open parenthesis, x, plus 2, closed parenthesis. Factor out the GCF of the expression. Analysis. We can check our work by multiplying. Use FOIL to confirm that. Open parenthesis, 5x, minus 3, closed parenthesis, multiplied by, open parenthesis, x, plus 2, closed parenthesis, equals 5x squared, plus 7x, minus 6. Try it number 3. Factor. A. 2x squared, plus 9x, plus 9. B. 6x squared, plus x, minus 1.